Okay, folks, so we come to the last page of the pre-work here, or the second to last page, I guess. And the first thing I want to say is that this tool of being able to find the slope of the tangent line is so versatile and useful that after a while we sometimes stop thinking about it as being a tool that gives us the slope of the tangent line, and we start looking at it through some other lenses. And for that reason we give it another name. We call it the derivative of f at a. So we're going to go ahead and write that this way. We're going to say, so rather than saying the derivative of f at a, we're going to use this notation right here. So for example, g prime of 7, or the derivative of g at x equals 7, is read as I just said, the derivative of g at x equals 7. Well, what would be read as the derivative of h at x equals 4? Go ahead and fill that in. So fill that in. I'm going to leave that to you. How would you say the derivative of h at x equals 4? What would you write using this as your guide? Okay, so because I said that this terminology, the derivative, is really just the same as the slope of the tangent line, it shouldn't surprise you what the definition of the derivative is. The derivative of f at the number x equals a is given by this limit definition right here. Notice that that is identical to the slope of the tangent line definition that we gave. So we say f prime of a, or the derivative of f at x equals a, is the limit of the difference quotient. So what does that mean? Well, we can't always calculate a limit. Not all functions, not every function will be able to calculate this limit for. So we have to add the caveat that this only works provided the limit exists. So let's go ahead and give the alternative definition to this. So we're defining the derivative of a function f at x equals a is given by this expression right here. I want to emphasize, especially for what we're going to do in the next section, that the derivative is we're taking the derivative at a number, we're taking the derivative at a point, and it's returning a slope of a tangent line. So that's why I'm having you write the number right there. But what is this alternative definition? It will be that f prime of a is equal to the limit as x approaches a. Notice the difference here. In this definition, h is approaching 0. In this definition, x is approaching a, of f of x minus f of a all over x minus a. So take a moment and confirm to yourself that these two definitions are really doing the same thing. And if you have trouble with that, think about the two definitions that we gave for the slope of the secant line. So using the same function that we had in number 10, which was the function f of x is equal to negative x squared minus 10x plus 7, let's go ahead and use this, the original limit definition, and let's calculate f prime of 2. So f prime of 2 is equal to the limit as h approaches 0. So 2 is playing the role of a in the definition, so what's that going to be? It's going to be f of 2 plus h minus f of 2 all over h. Well, that's equal to the limit as h approaches 0 of negative parentheses 2 plus h quantity squared minus 10 times 2 plus h plus 7. So this expression that I just wrote is this expression right here, minus parentheses negative 2x squared So let's go ahead and calculate f prime of 2 using the function from number 10 above with this limit definition of the derivative. So our goal is to practice using this derivative definition right here, and we're supposed to calculate f prime of 2, so that means that we're going to be using 2 in place of the expression a here. So we have f prime of 2 is equal to the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. Well, that's equal to the limit as h approaches 0 of, now I'm going to tailor the limit definition to this specific function. So everywhere I see an x in this expression, I'm going to plug in 2 plus h. So that's negative parentheses 2 plus h quantity squared plus 10, lost the plus sign, plus 10 times x plus times 2 plus h. Minus 7. So this, let me just put brackets around this expression. This entire expression right here is this piece of the limit definition, okay, minus, then we put a bracket, and so now I'm just going to take this function right here and I'm going to input 2, so negative 2 quantity squared plus 10 times 2 minus 7. And so this expression right here is just this expression in the definition of the derivative all over h. Okay. At this point, folks, this should seem like familiar work. It's the exact same limit that we've been working with in these in the past two sections. Okay. So the only difference is now we're calling this the derivative at x equals 2. So let's go ahead and finish computing this. We've got the limit as h approaches 0. Foiling this out is going to give me negative 4 minus 4 h minus 2h squared plus 20 plus 10h minus 7, and then we'll have plus 4 minus 20 plus 7 all divided by h. As we've said a few times now, notice that all the terms, because this is a polynomial, all the terms that don't have an h in them end up canceling out. And so what are we left with? We're left with the limit as h approaches 0 of negative 4h minus 2h squared plus 10h all over h. When we cancel all the h's out, we're left with the limit as h approaches 0 of negative 4 minus 2h plus 10. And now we can apply the direct substitution property. We end up with negative 4 minus 2 times 0 plus 10, which gives us a slope of 6. Okay. If we go back and we look at the graph from the previous page, we notice that at x equals 2, if we were to draw a tangent line there at this point, we find that the slope of that tangent line is equal to 6. Notice now, unlike what we were doing way back in chapter 2, I'm not writing the slope as approximately 6. I'm writing the slope of the tangent line at that point is actually equal to 6. Okay, so I'm going to leave you to do the last two problems on your own. For number 19, I want you to calculate f prime of 5 for this same function here, but I want you to use this alternative definition, this alternative definition here. So you're practicing using the second definition. We'll set it up. We'd say that f prime of 5 is equal to the limit as, careful here, what do we write? We're going to put as x approaches 5 of f of x minus f of 5 all over x minus 5. And then you're going to go ahead and compute this difference quotient and then take the limit. Finally, I want you to go ahead and explain why that answer comes out to be 0. So after you're done working this problem, you should find that the answer is 0. Then look back at the graph at number 10 and explain graphically why that's the case. Okay, folks, that's all I've got for you, and we'll see you in class next time.